This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. This is part 8 of Vector Basics. We're going to do this problem. So we've got a vector u, and these are its components, 3, -1. We want to draw u, then we want to draw negative u and state its component form. And we're going to draw 2u and state its component form. Right, so we've got this u. Now remember, it doesn't matter where you draw vector u. You could start it anywhere you want. So let's say we drew vector u starting way over here on the left, and I would go, so here's my starting point. I would go over 3 and down 1, and there's my end point. And that is one place I could draw it. You could put it anywhere. If you start it at the origin, so it would be like this. Anytime the initial point, the starting point, is at the origin, this is called the position vector. You position it in a specific place where it always starts at the origin. So that is the position vector of u. All right, so just keep in mind, you don't have to put it there, but if I do put it here, that's the position vector. All right, next thing. So we drew u, and I drew it again. All right, how about drawing negative u? Again, I could start it right here, where the tail, the initial point, is at the origin, or I could draw it anywhere else. How about I start it here, and it looks just like u, except it's going the other direction, right? So let's see. By just kind of free drawing it from what we did in the last video, it would look like this, same length, same direction, etc. And now look at that. What would that position vector be if I were going to name its coordinates? So this is negative u, because that's what it says. Draw negative u and then state its not its coordinates. I meant to say in component form. So what's the component form of negative u? Right, what would that be? Negative u. Well, look at it. So if I start here, I would have to go to the left 3 and up 1. So it's -3, 1. Okay, now let's go ahead and do 2u, right? I'm going to erase this position vector now. All right, so how are we going to draw 2u? I'm going to go ahead and start it, make this one a position vector. I'm going to have to draw u the same direction, but make it twice as long. So let's see. If I go over 3 and down 1, and I drew it, that would not be twice as long yet. But if I did it again from here and down 1, I would now have 2u. So this is 2u, and this is the position vector, by the way, of 2u. Okay? Now we want to know what the components of 2u are. All right, so let's see. I would have had, here's my starting point. I would go over 6 and down 2. So in component form, 2u ends up being over 6 and down 2. It would be 6, -2. All right, so now look at this. We started out with u being 3, -1, and negative u ended up being -3, +1, and 2u ended up being 6, -2. Do you see an easy way of doing this without having to draw them first? It's almost as if the distributive property is being used. It's really not the distributive property, but it kind of looks the same way. If you're doing 2 times a vector in component form, each of the components is multiplied by that number. So if I have, let's do another problem. Oops. Let's see. So here's another problem. Let's take W equals negative 4, 3. Oops, don't want to have a parentheses. So what would 3W be? It ends up being 3 times negative 4 and 3 times 3. So it's negative 12, 9. So in general, here's how it works. If A is a scalar, remember A is just the number. A is a scalar, then A times some vector V. Let me write the vector V in component form. Let's say it is CD. Okay, so we have a vector here, because you know it's a vector by these pointed things here, is the same thing as AC AD. So that's how you do multiplication with scalar times a vector. Now what about if we're adding some combination like this? How about we have some vector negative 3, 2, and some other vector which is 4, 5. And the question is, what is 2v minus 3w? Well, let's just write the vector v in component form, negative 3, 2. Then we're subtracting 3 times w, which is just this component form. And so it's like the distributive property, except, you know, if this is how it works with vectors. It's not exactly the same one as multiplication over addition, but this will give you 2 times the negative 3 will be the first component here, and 2 times 2 is 4, minus, and this will be, and you could change this to plus and negative if you want, or keep it as minus, that's up to you. You could put 12, 15. I didn't go over this yet, but if you want to keep this as a minus, you're going to subtract the first coordinates and then subtract the second coordinates. So that'll be a negative 6 minus 12 and a form minus 15. If you would have changed this to plus and negative 3, you would end up with a plus sign here and a negative 12 and a negative 15. So the answer here will be negative 18, negative 11. And that's how you do this combination here. This is your Math Gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.